We are super excited to present you this international collaboration on the future of security advisories and how it ties together with current trends in security and supply chain. This talk is not about SBOM. You all know Allan, my colleague here, as the guy who won't shut up about SBOM, but today he won't talk about it. And that's a good thing, as SBOM is now in everyone's mind and it's not novel now. So Allan, what are we going to talk about today?
So instead, we're going to be talking about vulnerabilities. Now, this is Black Hat. We all know, we all love vulnerabilities. Some of them are fancy and have logos and theme music and are rolled out with press releases. Some of them are kept hidden, and you use them as your special stash when you're on in operation. But really, a lot of what we want to talk about today is the known vulnerabilities. And frankly, in security world, known vulnerabilities should be among the easiest parts, right? It doesn't require a particular approach or particular expertise because we already should know about them. And, of course, bad guys know about them too. Now, we're going to know a lot more about potential vulnerabilities down the road for certain reasons that we won't get into here. There is going to be more visibility into our entire software supply chain stack. But what we want to get to, and the starting point, is how do we communicate vulnerabilities? And again, if these are known, there is going to be some frame of reference. The most common is CVE, Common Vulnerable Enumerations. But of course, there might be other vulnerability databases. There may be private ones that you subscribe to. If you want to know more about that and why you can't rely on certain of the more commonly used ones, go talk to Jay Coons. He'll tell you all about it. But essentially, the focus is we have a common frame of reference or frames of reference to communicate vulnerabilities. But suppose we don't just want to know what they are. We also want to be able to communicate which versions are affected, a little more details, what remediations are there. Well, we have security advisories. And so we're going to be spending some time talking to you today about security advisories. But before we get into that, I want to point out a very common thing that, alas, far too many folks in security forget, which is that not all vulnerabilities are actually exploitable or actually things that bad guys can use. Now, I'm not talking about vulnerabilities that aren't exploited in the wild. That's a very interesting problem. There's lots of great, exciting research that's coming out about how to predict which ones are actually being exploited. But what we're talking about is exploitable. So, for example, OpenSSL 1.0.1, also known as the code in which we found the Heartbleed bug, has, depending on how you measure it, between 600 and 1,000 different function calls you can make. 2 of them actually call the code, the heartbeat function, that then allows reading of random memory space that you're worried about having to go fix it. So, if you're only using Heartbleed, or if you're only using OpenSSL for, say, the pseudo-random number generator, I don't know why you would use OpenSSL pseudo-random number generator as a freestanding function, but this wouldn't affect your code. And some estimates from vendors say actually the amount of vulnerable code that's actually affected is quite low. Some put it below 10% of vulnerable libraries that once you're using them, the vulnerability actually is manifest in the code. So we need a way to communicate that your product is not affected. So for example, the Zephyr IoT real-time operating system, that's an open source project produced by the Linux Foundation, or part of the Linux Foundation. When the Amnesia 33 vulnerability with its fancy logo, some great research by JSOF and Forescout, came out, the good folks in the Zephyr project said, hey, let's actually make sure that's not affected, because this is supposed to affect, potentially tens of millions of IoT devices. So they wanted to say ours were not affected. So they did the work, and they had to produce, and they released a statement saying, we heard about this. We even had advance notice because we're doing good vulnerability coordination, multi-party coordination. We analyzed these vulnerabilities, we looked at the affected code, and we determined that our project was not affected. Now, that's great. That's exactly what good product security teams should be doing. The challenge is that this doesn't really scale. So imagine if you're using Zephyr on your plant, well, you've got a bunch of different things that you need to map that to, but also you're using a whole bunch of other devices on your plant. So you've got 5 vendors, 10 vendors, hundreds of vendors. When you talk to shops that are more than just basic office shops, you're going to find out that they're using hundreds or even thousands of different suppliers. So doing this is going to be quite tricky. So how do we communicate that a device or piece of software is not actually exploitable? And the answer is a new idea called the Vulnerability Exploitability Exchange, or VEX. Now, a couple of things to clarify about VEX. First is, while the term exploitable is in the name, we're a little too experienced in InfoSec to want to get into a discussionary debate about exactly what we mean by exploitable. We'd much rather talk about what our favorite text editor is and why it's better than yours. So we're going to be using the term affected. Not, gosh, Allan is really pretentious and affected, but do I need to do anything? So another way of defining it is that a piece of software is affected by a vulnerability if there are really any actions that are needed or recommended to remediate or address this. Now, the actions could just include learning more about the vulnerability, making a decision to patch, apply defense in depth. There are a lot of things. It could just be as simple as, hey, you remember when we explicitly told you not to plug your product into the internet? Could you please make sure that you follow that very simple step? So it really covers any side of things. Now, the opposite of affected is, of course, not affected. And this means you're good. No remediation is required for this vulnerability. Now, this could be because the vulnerable software isn't executed, could mean that the vulnerable code was excluded from in the compiler, but just didn't include it in the compiling or do conditional compiler statements. Could be that existing security controls make it impossible to exploit. It could be the vulnerable code was fixed by a downstream developer. There are a lot of different reasons that we can go into, but we're not going to touch on just now. So what do we actually need for VEX? We don't need that much. We need, apart from a slightly better name than VEX, but it's one we're going with for the moment. So we need a descriptive data model for the software, right? How do I talk about what I'm talking about? And we need this vulnerability status, starting off with high level, right? Affected or not affected, and then moving on. And it needs to be machine readable, and it needs to be automatable. So what are the fields that we have here? Well, we need the metadata. We need, where did this information come from? Who's the author? Right, what's the timestamp? What products are we talking about? So for example, we could talk about multiple different products. And then for each product, there might be vulnerabilities that we want to say. What's the ID? What are some of the vulnerability details? What's the status, affected or not affected? And then either an action statement, which is what are the remediations, what do I need to do? Or an impact statement, which is why you're not affected. So having some ideas. Now, that sounds a lot like a security advisory. Now, you remember security advisories, right? You've probably had 1 or 2 or 3 or many that you've had to deal with in your life. And that's one of the big challenges is security advisories proliferate. So now we're proposing a new idea, which is that we should have negative security advisories, where we can sort of convey, in addition to is affected, where you're trying to use the same idea, but saying, let's have a security advisory that communicates that something is potentially not affected.
As Allan has told us, we should look into security advisories first and see what is already there. So we have a lot of different vendors here, but as you can see, there are different websites, and it doesn't really has this part of automation in it. And it gets even worse if you look into the single security advisory then. You have them in different file formats, so HTML, PDF, text, and you also have them in all of different specifications. So the one puts your affected products on top and then puts all the other text blobs below, and it gets all different structures here, and it's not really machine readable. It's built for humans to read them, and it has all this fancy corporate design in it. So what could we do? At first, we should take a look at our timeline of disclosure. Our timeline of concern is basically from when the vendor does release a security advisory and then until the asset owner does something. And we can shorten that by looking into the process and put in automation. But how do we automate security advisories? Well, the answer to that is the Common Security Advisory Framework, CSAF, and that's one of the other part which is the main part of our presentation today. CSAF is currently published in the version 2.0. It's a JSON format. It is machine readable, and it's really built with automation in mind. If you know CVRF, CSAF is its successor, and it's standardized in an industry-led process at the OASIS Open. So if you look at the process today, a vendor produces human-readable security advisories, say 15 advisories with different severity, and then you as a user have to go to the websites, find the new or updated advisories, and download them. After you have downloaded them, you have to prioritize them for their criticality, so that you actually care about the most important first. And then you start with your asset database and look into, do I have affected devices? If not perfect, scratch them off the list. And if you have affected devices, you do your risk assessment and decide what decisions you want to do. If we could automate that, well, the vendor obviously had to release machine-readable security advisories and publish them. But then really automation kicks in and gets us off the first step. Finding these advisories, that's a simple and boring task, so we should automate that and get them downloaded. But then we get a second benefit here as the step of, do I have affected devices? So the evaluation can also be done in an automated fashion. So compare that to your asset database, and then you got only those advisories where you all have affected devices. But there's a second thing here which you can actually add to the process, as maybe say advisory number 9 is something which is internet facing, and you're really worried about that an adversary can come in through that vulnerability. You prioritize the security advisory based on your infrastructure. And maybe number 12, that's something buried way down in your OT network, so multiple layers of defense and depth around that and detection. So that's probably something which you can worry a little bit later about. And then you do your measures, you sift through the advisories where you have affected devices for, and decide what you want to do with them. Now you need tools for that to do the automation, and we already defined in the standard 2 tools which will help you to do that, and that's the CSAF content management system on the vendor side and the CSAF asset matching system on the asset owner. So hopefully you can go in a few months into your commercial off-the-shelf software provider and get that software, or even have an open source project which provides that software to you. But what are the benefits here? Well, we are reducing the human workload. We don't have to search this boring search stuff for new advisories. We can easily determine the affected devices. We can even delegate this decision process to those business units who actually are responsible for the devices, and we see only the relevant advisories. As it is machine readable, you don't have to worry about the corporate design stuff, so it's scalable across vendors, and you can do your risk assessment based on your own environment. But how does that help us in the supply chain? Well, every supplier is a user. So if you look at our supply chain a little bit more upstream than we had before, then you see the supplier is basically doing the same as the vendor. So he also releases an advisory, and then the vendor becomes aware of the vulnerability. So let's look at that time frame now and see how it might help there. Since if we could automate that part, it would go much further through the supply chain. So we have similar benefits here. We can scale that across our suppliers. We don't have to do this searching for security advisories manually. We can determine our affected devices easily. We can even delegate that to the product owners and make them responsible to look out for security. And we can automate our advisory creation. Now, if you have SBOMs internally, which you already should, then you could already automate that. But Allan, what does that mean for VEX?
So this is great news for VEX, because now we're working on putting VEX as a profile in CSAF. This is great news because now we can use the same infrastructure and the same systems that we're using for CSAF to communicate VEX and also to ingest VEX. So we're building on an existing system. Now, there may be other ways that we can implement VEX as well. So for example, inside Cyclone DX, but really the VEX profile allows great scaling across organizations and to integrate it into this work as well. Now, part of the benefit here is that your product security team is already doing this work. Now, that's a core assumption. We're saying that for this to work, you need to have a product security team and that they have some process for analyzing vulnerability data. If your organization does not have a product security team and you don't have the ability to analyze vulnerability data for your product, it's a little late in the talk to say this, but please stop watching this right now and spend the next 5 or 10 minutes working on that. That really is a priority. Once you have that, then we say, well, listen, you're already doing this already. So there's some advantages here to actually making this information public. Core one is this can save on customer support. So if you can communicate downstream that there is no vulnerability that doesn't affect your product, it means that your customers won't be bothering you. And I've talked to countless vendors who, when a major vulnerability comes out, the first thing that happens the next morning is they get calls from all their major customers saying, hey, are you affected? Have you fixed this yet? And so having an automated way to communicate that will be very, very helpful. And in fact, there's a field we didn't touch on, which says this is under research. We know about this, and we're actively trying to figure it out so that customers will be able to look and know that an automated response is going to be coming soon. And in fact, when I've talked to some vendors, they've sort of announced, hey, even when vulnerabilities are announced in our competitors' products, people still ask us. So there may be companies that will want to issue an affirmative denial, even if a vulnerability isn't anywhere near their product. They may say, hey, listen, we're going to affirmatively say that it's not, even though there's no reason anyone would expect so. The other approach here is that this data is coming straight from the source, but the source can vary. One of the fields in CSAF is, and one of the benefits of CSAF is anyone can issue a security advisory, and it's up to the customer to decide which to trust and which not to trust, because there is some mechanism for authenticity in there. So the vision is that, Ideally, the product security team will say this is affected, it's not affected, but there's plenty of room for other people as well. This is a great opportunity for security researchers to talk about things, to validate that they've got the expertise, and for security companies and security vendors to say, you know what, we can do value add for vulnerability management process or for prioritization process, and we can provide real value for our customers, not just in which vulnerabilities they should pay attention to, but which ones they shouldn't. And in fact, we're implementing this today, or we're starting to, in not the most advanced IT sector in the world, although some of the major leading tech vendors are working on implementing CSAF and VEX. But I think even more impressive, we're seeing this being implemented by healthcare providers and by medical device manufacturers, not necessarily the sector that you think of as the vanguard of high-end cybersecurity investment. But it is a community where, one, security is very important, and two, patching can actually, and security updates, imposes a real cost, right? You need to take things offline. You may not want to do it on a live network. And that means potentially saying, well, now I've got to find, a way of caring for this patient while I take this important device and make sure that it's updated. So the security management can actually impinge patient care. The more efficient and automated we can make that, it's going to have real benefits, not just for security, but for literal human health and safety. So I think we've got this problem completely solved. Right, Thomas?
Well, Allan, nearly solved. We still need you, the audience, to help us to make that work. And now I know what you're going to say. Well, security, nice talk. I probably do that next month. Well, here are 3 actions for you, which you can start doing right now. Well, the first one, pretty easy, request your suppliers to provide their advisories in CSAF so that you can actually automate process them. And if you write a security advisory, provide that at CSAF. There's already tools out there which you can use. One of them is SecVasogram, and they also give you the human-readable advisory for free. So it's nothing different than writing an advisory for you, just putting him in a machine-readable format. And the third and most important one is spread a word. So we put in some hashtags for you to use on Twitter or any social platform you want to use that on. And please don't forget about SBOM. Let's sum it up. The numbers of vulnerabilities discovered is rising. And that's good for the security researchers who discover them, and it's good for us who are actually getting that vulnerabilities fixed. And we get better insights in our supply chains, so we will have more advisories over time. And we really need those advisories to make those risk-based decisions, as Allan has told us, also in the healthcare sector, where patient care is related to security, but also in other sectors as well. Our manual process, which we deal today with, it doesn't really scale, but automation is possible. So go ahead, automate the boring stuff. And also publish the known not affected to save your support hotline, the questions, and inform your customers in a timely manner. Come, join us here and help us, or offer constructive criticism. We're open to that. And we look forward to having you join the conversation. Thank you.
Thank you.